So welcome to s.mathguru classes. Our main discussion is homogeneous Cauchy Euler homogeneous linear differential equation. Now homogeneous differential equation, linear differential equation, we solve some problems and some rules also given when how to know that this is homogeneous differential equation. Here the power of x is cube and order is 3. Power of x 2, order 2. So obviously this is homogeneous linear differential equation. If it is homogeneous, then for solving this problem, we consider put or putting x equal to e to the power z, log x equal to z, and d dz equal to capital D. So we get this. Now x cube d cube y dx cube x square d square y dx square minus 2y x 1 by x cube. So for this we can write d minus 1 d minus 2. We can write this. And for this x square, then we write d minus 1 minus 2, and y is common. From these y common, and right hand side x means e to the power z, and this is 1 by e to the power z whole cube. If we multiplying this we get d square minus 3d plus 2 plus d square minus d minus 2y e to the power z e to the power 3z. We get this. And multiplying this d cube minus 3d square plus twice d plus d square minus d minus 2 y, this is e to the power z e to the power minus 3z. We get this. This implies d cube minus 2d square plus d minus 2 y equal to e to the power z minus e to the power 3z. If we calculate, we get this one. Now auxiliary equation m cube 2m square plus m minus 2 equal to 0, and from this 2m square common, m minus 2, here 1 common, m minus 2 equal to 0, m minus 2 common, m square plus 1 equal to 0. So m equal to 2 and m equal to plus minus I. We get this one. So complementary function CF equal to C1 e to the power 2z plus this is I C2 cos z plus C3 sin z. We get this. For this we write e to the power 2z, and this is complex number, we get C2 cos z C3 sin z. We get this. Now particular integral. Particular integral is right hand side by this. Right hand side is e to the power z minus e to the power minus 3z divided by d cube minus 2d square plus d minus 2. We get this. And this equal to e to the power z d cube minus 2d square plus d minus 2 minus e to the power 3z by d cube 2d square plus d minus 2. And this is exponential, coefficient of z is 1, putting 1. in place of d. 1 cube 2 into 1 square plus 1 minus 2, and e to the power minus 3z, and coefficient of z is minus 3, putting here minus 3. Minus 3 square 2 into minus, this is minus 3 cube, minus 3 square minus 3 minus 2. So this will be e to the power z by 1 minus 2 plus 1 minus 2, e to the power minus 3z minus 27 minus 18 minus 5, e to the power z minus 2, and this is 50 minus 50, so plus 3z by 50, minus 50 minus minus plus we get this is our particular integral. Therefore general solution is y equal to CF plus PI. Y equal to CF means C1 e to the power 2z e to the power 2z plus C2 cos z C3 sin z minus 1 by 2 e to the power z 1 by 50 e to the power 3z. So this can be written as y equal to C1 e to the power z whole square, C2 cos z, C3 sin z 1 by 2 e to the power z 1 by 50 e to the power z whole to the power minus 3. But e to the power z means x. Originally our problem is x, answer must be in terms of x. So y equal to C1 e to the power z means x, C2 and z means log x, cos of log x, C3 sin of log x, 1 by 2 x 1 by 50 x to the power minus 3. We get this one. Now finally we can write this is answer. We can write 1 by x cube also, and this is the final answer. C1 x square, C2 cos of log x, C3 sin of log x minus 1 by 2x and 1 by 50, or we can write minus 1 by x cube also, this one, and this is the final answer of the given problem. Very easy solution. I consider another problem. It's also homogeneous. This is x cube, this third order, x square, second order, x, first order, this y. So this is our problem. This is also homogeneous linear differential equation. Now solution. So we put x equal to e to the power z, log x equal to log x equal to z, and d dz equal to capital D. So we consider this is number 1. Now 1 implies this will be d minus 1 d minus 2, and this is 3 d minus 1, this is d, this is 1, and y is common from this y common, and right hand side x means e to the power z and log x means z. We get this, and multiplying this is d square minus 3d plus 2. If we multiplying this, we get this one plus 3d square minus 3d plus d plus 1 y e to the power z plus z. and this is d cube 3d square plus twice d 3d square minus twice d plus 1 y equal to e to the power z plus z. 3d square, these are cancel, twice d cancel, we get d cube plus 1 y equal to e to the power z plus z. We get this one. Now auxiliary equation m cube plus 1 equal to 0. We know from lower class a cube plus b cube equal to a plus b a square minus ab plus b square. We know this formula. This is 1 cube, m cube, 1 cube, a cube plus b cube. So this can be written as m plus 1 m square minus m plus 1 equal to 0. So this is m equal to minus 1 m square minus m plus 1 equal to 0. But this one unable to factorize. If we are unable to factorize, then we consider the quadratic formula. This is a quadratic equation. Then x equal to, we know, minus b plus minus root over b square minus 4ac by twice a. We know this formula. Here using this formula, we get m equal to minus 1 minus b, that means minus 1, plus minus root over minus 1 whole square 4 into 1 into 1 by 2 into 1. This is 2 1 plus minus 1 minus 4. This one 2 1 plus minus minus 3. This is 2 1 plus minus I root 3, or we can write 1 by 2 plus minus I root 3 by 2. Therefore, what we get, m equal to minus 1 and m equal to 1 by 2 plus minus I root 3 by 2. This is the value of m. Now complementary function. Now complementary function equal to, first value is this, we consider one constant c1 e to the power minus 1z, and this is e to the power 1 by 2z c2 cos root 3 by 2z plus c3 sin root 3 by 2z. These are complementary function. Now particular integral. Particular integral is right hand side e to the power z plus z by d cube plus 1. We get this. Now we separate this e to the power z by d cube plus 1 z by d cube plus 1. This is coefficient of z is 1, then putting here 1 cube plus 1, and this is z by 1 plus d cube e to the power z by 2 plus 1 plus d cube whole to the power minus 1 z. But original formula we know 1 plus x whole to the power minus 1 equal to 1 minus x plus x square minus x cube plus dot dot dot. We know this formula. Now if we using this formula e to the power z by 2, this is 1 minus d cube plus d to the power 6 dot dot dot, and this is z. Other term no need to write because our power of z is 1, and multiplying here we get this will be e to the power z by 2 z minus 0, z multiplying here z, d cube z is 0. So we get e to the power z by 2 plus z. So this is our particular integral. Now general solution. General solution is y equal to complementary function plus particular integral, and complementary function is this c1 e to the power minus z e to the power 1 by 2 z c2 cos root 3 by 2 z plus c3 sin root 3 by 2 z plus pi e to the power z by 2 plus z. We get this. Now we write this c1 by, so we can write this is e to the power z to the power minus 1, and this is e to the power z to the power half c2 cos root 3 by 2 z c3 sin root 3 by 2 z plus e to the power z by 2 plus z. We get this, and putting the value of x, this is e to the power z means x and z equal to log x. Putting here, this is c1 x to the power minus 1 x to the power half, this is half means this is 1 by 2 c2 cos root 3 by 2 log x c3 sin root 3 by 2 log x plus x by 2 plus log x, this one. So or we can write c1 by x, this is root x, and this will be c2 cos of root 3 by 2 log x c3 sin of root 3 by 2 log x plus x by 2 plus log x. So this is our final answer, x by 2 log x, and this is c1 by x root x c2 cos of root 3 by 2 log x c3 sin root 3 by 2 log x plus x by 2 this log x. This is our final answer. So if you are enjoying with this video, then please share to your friends, and if you are new in my channel, please subscribe my channel and click the bell icon. Thank you.